All right, I think this is recording. Let's take a look here at number one. They want us to solve this triangle. Whenever they ask us to solve a triangle, they want the measurement of the three angles and the length of the three sides. Well, they give us half of that information right off the bat, so we have to find the other half. Now, let's look at what we've got here. We've got the measure of angle A, which is 22 degrees, and we've got the length of side A, and then the length of B, 55 here. So we have two sides and the non-included angle. This is referred to as the ambiguous case because just with that information, just knowing it's the side-side angle, there's several possibilities. We could have no solution where you can't form a triangle. We might have a situation where you can form exactly one triangle, and that triangle might be an obtuse triangle, or we might have a right triangle. Or we could have two triangles, two acute triangles. So we need to figure out which of these cases we have and then proceed from there. Well, I kind of have to always orient my triangle and draw it. I like to draw the side here, and I like to put this angle right here, 22. Opposite here is 27, and this is 55. And right here, I think of this as a hinge where, like a pendulum of a clock, this side can swing back and forth. Okay, and that's going to be a nice visual aid for me in just a second. So the first situation that I have here, 27 would have to be longer than 55 to have the obtuse triangle. So I know that I'm not going to have this situation. Well, I need to see if that 27 fits in there just perfect to come down and touch this side and form a right triangle. So I need to find the height of this vertex right here. Well, I can do it using the sine. The sine of 22 degrees is the opposite leg, which I've labeled h, over the hypotenuse, which is 55. So if we take 55 times the sine of 22, and we're going to compare that number against this 27. So let's come down and use our calculator. Let's check, we're in radians, we need to be in degrees. And I'm just going to have it fixed around to 2 decimal places. That ought to be good enough for us. All right, so I want to take 55 times the sine of 22 degrees and compare that number against the 27. So 20.6. Okay, so they didn't tell me whether this was inches, feet, meters, so I'm just going to call it 27 units. Well, that 27 can definitely cover that height. 27 is long enough that it can reach this other side. Okay, 27 is bigger than that 20. So remember that we talked about it being a pendulum. If I can have this triangle, or let's see, I'll try and draw it right below it. 22, 55. This 27, imagine rather than being swung out to the right, what if we swing that out to the other direction? What if we swing it in over here? Okay, so it's come in, I'm putting it right there, and you can see on the left here that it forms a different triangle. And we want to find the measurements of both of these triangles. All right, so now that we know that we have the two triangle case, I'm going to erase this stuff and come in and now I know what I'm looking for. So we'll start with the known pair, an angle and its length opposite. So I'm going to start with the sine of A over A. And the law of sines tells me that that fraction, that ratio, is going to be the same as the sine of angle B divided by the length of B. Now, I'm not going to pick C to start with over here on the right side because I don't know angle C and I don't know the length of C. And although I don't know the measure of angle B, I do know the length of B. So I know 3 of these 4 things. So I know that A is 22 degrees. And I know the length of A is 27. And I don't know the sine, I don't know the angle, measure of angle B, but I do know the length of B is 55. So I can solve this equation for the sine of angle B. Like this. Well, I want to go to the calculator and figure out what the measure of angle B is. So let's do that. If I take this first, let's figure out the sine of B by just taking the sine of 55 that we've already found, or excuse me, 55 times the sine of 22. I want to divide that by 27. Now, that's not angle B, that's the sine of B. So if I take the inverse sine of that answer, there's the measure of angle B. All right, it's 49.74. Now let's shrink this up a little bit. Let's come over and use a different color. Over here at angle B, we've got 49.74 degrees. All right, so now I have 2 of the 3 angle measures. We know that we have a triangle angle sum theorem that says the angles inside of a triangle always add up to 180. So we can easily figure out what the measure of angle C has to be, because it's going to be 180 degrees minus the sum of A and B. Well, A was given as 22, and we just figured out that the measure of angle B was 49.74. So this can tell us the measure of angle C. So let's jump to the calculator. We've got 180 minus the sum of 22, that given angle, and that angle that we found by using the scientific calculator, the inverse. So 108.26 degrees. 108.26 degrees. So let's put that in our triangle. It's kind of big, so I'm going to put it over here. 108.26 degrees. So now I want to come back to this, the sine of A over A, this given ratio. And not only is it equal to the sine of B over B, but it's equal to the sine of C over C. And we've got the sine of 22 degrees over 27. And we know the measure of angle C is at 108.26 over C. So I'm going to have to continue up here. I want to cross multiply and then divide by the sine of 22. So what I'm going to do is come in here and multiply this diagonal together, then multiply this diagonal together. So when I multiply that green diagonal, I get 27 times the sine of 108 0.26 degrees. When I multiply it along this yellow diagonal, I get C, the length of C, times the sine of 22. Well, I want to get the C by itself, so I'm going to divide by the sine of 22 immediately to get that C by itself. So now, let's go to the calculator, and it will give us the last measurement we need for our first triangle. So let's see what we've got. In the numerator, we've got 27 times the sine of 108.26, close that parenthesis, then divide that by the sine of 22. So I'm getting 68.45 units, 68.45 units for the length of C. So that's one triangle. Well, I claim there's another triangle with this given information. So I'm going to erase this over here, and I'm going to erase this, but I'm going to go back to the very first time that we used the calculator to find an angle measure with the inverse sine. All right, now let's think about it. Remember that when we used the inverse sine, the calculator only looked in quadrants. It looked between negative 90 degrees and positive 90 degrees for a y coordinate that was whatever this number was. It treated it like a function. It only looked on it only looked on the right half of the unit circle. We know that over in quadrant 2, there's another point that has that same y coordinate that the calculator doesn't tell us what it is. So we know that there is a second angle measure B that we can treat this 49.74 as a reference angle. If we take 180 minus 49.74, this angle also has that same ratio. So let's come in and do that. If we take 180 minus 49.74, we're getting 130. 130.26. See, what I claim is that if I take the sine of 49.74 and I compare this against the sine of 130.26, it's going to be the same number. See, 0.76, or at least to 2 decimals. The first angle is in quadrant 1, the second angle is in quadrant 2, but both of those have points on that terminal side that have a y coordinate on that unit circle that's the same number. Okay, so now let's come over to our triangle. Let's erase. You've got the first set of numbers, so I want to erase these numbers that are in red if I can. And this is for our second triangle. We can put it in green. This is the measure of angle B. We're saying it could be 130.26 degrees. All right, so we know the triangles have to add up. That green is hard to see. I'm going to go to red. That if I take 180 minus my given angle of 22, and this instead of 49.74, this angle B that's in quadrant 2, this is going to give me another possibility for the measure of angle C. So if I have 180 minus 22 plus 130.26, 27.74, 27.74 degrees. These three angles add up to 180. Now, let's return back to that. See, the given information is the same in each triangle. So the sign of A over A has never changed throughout this problem because this information about the A's is the same in each triangle. But our information of the measure of angle B changed. It had two possibilities. Well, now I want to find I'm trying to find the length of C. So I'm going to take the sine of angle C over C. So let's come over here. We've got the sine of 22 over 27. And we've got the sine of, here's our measure of angle C in our second triangle, 27.74 degrees. And we want to find that length C for this second triangle. So again, we're going to cross multiply. So let's multiply along this diagonal, and then let's multiply along this diagonal. So we've got C times the sine of 22 degrees along the gold diagonal, and 27 times the sine of 27.74 along the green diagonal. To solve for C, let's divide by the sine of 22. And then that way we'll have this length of C. Yeah. So let's go to the calculator. Yeah, I'm going to clear it out. 27 times the sine of 27.74. Don't forget to close that parenthesis and then divide that by the sine of 22. And I get 33.55 if I haven't made a mistake. All right, so let's come over 33.55. All right, well, that should do it. We found the solutions, the measurements of both triangles. Hope that helps, and I'll talk to you later. Bye.